Welcome to Brain Vision.
In the first situation, we have two forces acting on the same direction with the same intensity. Let me call this force F. Then, in the first situation, Newton's second law tells us the following. The net force is equal to the mass times the acceleration. The net force is equal to 2 times F, and it is equal to the mass times the acceleration. Then, the acceleration is equal to 2 times F divided by the mass. Now, we can relate the acceleration with the displacement using the following relation. Remember that the displacement is equal to the initial velocity times the time interval plus the acceleration times the time interval squared divided by 2. The initial velocity is equal to 0 as the probe departs from rest. Then, the displacement is equal to the acceleration times the time squared divided by 2. Then, we can now solve for the time to get the following. 2 times the displacement is equal to the acceleration times the time interval squared. Then the time interval squared is equal to 2 times the displacement divided by the acceleration. Then the time interval is equal to the square root of 2 times the displacement divided by the acceleration. And it's equal to 28 seconds in this situation. Now we can repeat this calculation for the second situation. But on the second situation we have two forces that act perpendicular to one another. So F here and F here. We begin by calculating what is the magnitude of the net force. We have the following. There is one force that is acting on the x-axis, another force that is acting on the y-axis, and the result is a net force that is some kind of diagonal. So this will be the net force. What is the magnitude of the net force? It's very easy to solve this question because we have a rectangle triangle here, so we can use the Pythagorean theorem to discover what is the value of the net force. So the net force squared is equal to F squared plus F squared. Then the net force squared is equal to 2 times the force squared. So the net force is equal to the square root of 2 times the force F. Now, using Newton's second law, we have the following. The net force is equal to the mass times the acceleration of the probe. Let me call it A prime because this is a different acceleration because this is a different situation. So, square root of 2 times F is equal to the mass times the new acceleration. So the new acceleration is equal to the square root of 2 times F divided by m. We can relate this acceleration with this other acceleration by noting the following. A is equal to the square root of 2 times A prime. Then we can use this relation, only changing A by A prime to get the following. Delta t is equal to the square root of 2 times delta s divided by A prime. But A prime is equal to A divided by the square root of 2. So we have 2 delta s divided by A divided by square root of 2. And this is equal to square root of 2 delta s divided by A times the square root of 2. Then we have delta t is equal to the square root of 2 times delta s divided by A, the previous acceleration, times the square root of the square root. So we have the fourth squared of 2. The first term, we know that is equal to 28 seconds. We know this from the previous situation. Then, in this situation, the time interval is equal to 28 times the fourth square root of 2. And this is approximately 33 seconds.